Today, we are here. And to get to this point, we've been through a lot. Let's take a look into the past. Around 200 years ago, factories had just started using steam engines. About 5,000 years ago, we began learning how to write. And 200 to 300,000 years ago, we had just existed. But even before we were here, the world was far from empty. 2 million years ago, other kinds of humans roamed our planet. Earth itself only formed 4.5 billion years ago. And yep, the universe began nearly 14 billion years ago. Scientists have found strong scientific evidence to trace back the universe's past. But one big question remains. If we've often looked back in this direction, what about the other way, the end of the universe? What's going to happen at the very end? Up until now, so many scenarios have been developed about how the universe might end. Back in the day, this question was mostly discussed by philosophers, and even among them, there were a lot of disagreeing opinions. But that's as far as it went, just opinions. It took thousands of years before we finally developed telescopes to observe objects in space. Then we figured out how gravity works, how it pulls celestial objects toward each other. And eventually, we discovered the theory of relativity, which basically says that our universe works like a fabric of space-time. And when an object sits on it, the fabric bends around it. Here's the crazy part. Based on the theory of relativity, scientists calculated that the universe could not possibly be in a static state. At the time, a lot of people did not believe it, until one researcher managed to observe that the calculations were correct. Space is expanding. To picture this, imagine the universe as a raisin cake being baked. The galaxies are the raisins. At first, they're close together, but as the cake expands, the raisins move farther apart. This discovery completely changed how scientists saw the universe. And with that, a new question arose. If our universe is expanding now, will it keep going forever? Or will one day it eventually stop? This is where scientists proposed one possible way the universe could end: the Big Crunch. Alright, we've seen the universe is constantly expanding, but we also knew there's a force that pulls things together: gravity. Now imagine these two forces in a race. If gravity wins, the universe will stop expanding and start shrinking instead. At this stage, everything in the universe will be pulled toward each other, eventually colliding. Galaxies will merge, stars will crash into one another, and then they will be destroyed, replaced by black holes popping up everywhere. And yes, even these black holes will start devouring each other, forming one supermassive black hole that swallows everything in the universe. Until, in the end, all that remains is a mysterious point of infinite density, so extreme that the laws of physics cannot explain it: a singularity. Almost like we're back at the very beginning of the universe. Well, does that mean our journey will end where it began? Well, not necessarily. This brings us to the second scenario, the Big Bounce. Similar to what we just talked about, the universe will shrink down to an incredibly tiny state, so extreme that our known laws of physics will no longer apply. But in this scenario, that point never actually reaches infinite density. And since physics as we know it breaks down, some researchers suggest that the contraction could stop. If that happens, the universe could start expanding again. If this scenario is true, then the Big Bang may have already happened more than once. Crazy, right? But unfortunately, the Big Bang scenario is becoming less popular. Why? Here's the thing. In physics, there's a rule that says everything in the universe naturally moves toward more disorder over time. The measure of this is called entropy. It applies to everything: order, position, shape, you name it. And once something becomes disordered, it's extremely difficult, if not impossible, to make it orderly again. As the universe expands, disorder keeps increasing. Entropy always goes up and never decreases. So, was the Big Bang actually a big bounce? Well, most likely, no. Because if the universe had ended and been reborn, its entropy should have been very high. But based on our observations, the universe after the Big Bang had very low entropy. Alright, so both of these scenarios are based on the same assumption, that one day the universe will stop expanding. But the big question is, will it really? So, will the universe stop expanding? The answer might be no. Recently, the universe has shown no signs of slowing down its expansion. In fact, scientists have discovered that it's actually expanding faster. But how? Well, here's the deal. To measure distances in space, scientists usually observe how bright or dim a star's light appears, kind of like using a candle in the dark. But for objects that are super far away, we need something even brighter. That's where a special type of stellar explosion comes in, one that shines incredibly bright with a consistent glow. And it's this kind of supernova. But then, something strange happened. One day, researchers noticed something odd. Some of these explosions looked dimmer than they should have been. In other words, the supernovae were quietly moving farther away from us. This meant that something was making the universe expand at an increasing speed. And since we had no clue what it was, we gave it a mysterious name, dark energy. And it's just so powerful that scientists now believe dark energy makes up most of our universe, which just keeps expanding and expanding and expanding. And now we arrive at another possible fate of the universe. In the far future, as space keeps expanding, there won't be any more massive collisions or cataclysmic destruction. Instead, galaxy clusters will drift farther and farther apart, and the universe will quite literally die on its own. The universe will become too vast and empty. There won't be enough particles clumping together to form new stars, while all the old ones burn out one by one. Eventually, only darkness will remain, filled with faint stars, the remnants of dead ones, and black holes, lingering for an unimaginably long time. In a way, the era of stars and light will be nothing more than a blink of an eye, and after that, only endless darkness for a trillion years. If a human could live forever, they would witness nothing. Alone, isolated, cold for eternity. Unless, of course, we don't even have that much time left. In this scenario, the universe isn't just expanding faster. It's accelerating at an increasing rate, like a snowball rolling downhill, getting bigger and faster as it goes. With this uncontrollable expansion, the universe will, quite literally, tear apart as it's pulled from all sides. First, galaxies will be ripped apart, and then stars and planets will follow. And eventually, even atoms themselves will be torn to shreds. This could happen because space itself would be expanding faster than the speed of light. But it doesn't stop there. In the end, even the very fabric of our dimensions will rip apart, until absolutely nothing remains. Alright, whichever scenario turns out right, one thing is for sure. This is all still super far in the future. Maybe we don't need to worry too much. Besides, humanity already has plenty of urgent problems to deal with right now. Education around the globe is full of gaps. Healthcare is still expensive. and the environment is suffering more, and war and genocide are happening all over the world. Maybe instead of stressing about what will happen billions and billions of years from now, there's a more pressing question. If everything could disappear in the blink of an eye, are we sure we've lived without regrets? Because honestly, it's not impossible that our universe could end way sooner than we think. Let's take a look at the fifth scenario. In quantum physics, everything around us is based on interactions with quantum fields. These fields currently exist in a stable state known as the vacuum state. A simple way to explain it is like this. Imagine a ball resting in a valley. It appears stable at that point. But what if there's actually a deeper valley hidden below it? If so, the ball is not truly in its most stable state. In quantum physics, there's a possibility that this ball could tunnel through the hill separating it from the lower valley through a process called quantum tunneling. If this happens, the ball would move to the true stable position. Now, if such a shift were to occur in our universe, it would mean a change in the stability of our quantum fields. And if the stability of a quantum field changes, everything in the universe will change as well. For example, particles in the universe have mass because they interact with the Higgs field. The shape of the valleys represents the energy potential of the Higgs field. If the Higgs field were to suddenly transition to a new, lower energy state, the masses of all particles could change or even disappear entirely. And if mass disappears, atoms become unstable. If atoms are unstable, everything falls apart. Our bodies, the ground, the earth, everything would be destroyed. This destruction would spread at the speed of light. It'll be like a TV getting unplugged. Bam! Without even realizing it, we will all be gone. This doomsday scenario is called vacuum decay. That said, this is still a speculative theory, and the chances of it happening are extremely small. But as long as there's even the tiniest possibility, it could theoretically happen at any time. So who knows, maybe a day after you watch this video, vacuum decay will occur, and that will be the end of us all. Talking about the end of the universe is something that could go on forever. Scientists are still calculating, observing, and debating to determine the most reasonable ending for our world. What used to be just abstract ideas from philosophers now has actual scientific equations behind it. But now that we've reached this point, you might have a question. What's the point of thinking about all this? Why has this topic fascinated so many people for so long? The truth is, if we think it's pointless, we're actually missing something. We can look at it like playing a game. When we try to figure out how to defeat the final boss, we end up understanding the game's mechanics better. In trying to guess how the universe might end, we're actually learning more about the fundamental laws of physics. And if you're still asking why we do this, maybe the answer is as simple as because we can. Out of the millions of species on Earth across the billions of years our galaxy has existed, humans might be the only ones with the curiosity to ask and explore things all the way to their roots. A long time ago, our ancestors probably only wondered about lightning and the changing of seasons. But now, we've grown to ask even bigger questions about ourselves, about space, and even about the universe.